talking about special cases, what we mean by this are these ideas. Okay, so this is a this is like when you have x plus a quantity squared. Okay, so let's go through. So this means the variable. This means this is the variable. And this is the constant. Now you might say, oh, Miss Thompson, those are both letters. Correct, but one is the variable and one is the constant. Remember, mathematics is a language. This is a code, okay? I'm teaching you how to read the code, okay? So the parentheses are meaning that this entire thing is the base, and this is the exponent. So when you do this special case, okay, you've got the base multiplied by itself 2 times, okay? 2, so 1, 1, 2. I'm going to delete this because this is our second thing we're going to do, but we'll do it in a moment, and it's in the way. So that's how this is set up. Now, the FOIL, remember this? Okay. You could also put it in the square. Remember multiplying in the square. X, A, and we're multiplying. Okay. Remember, this is first, outer, inner, last, FOIL. First, outer, inner, last. You're multiplying. So x times x is x squared. X times a is xa. X times a is xa. A times a is a squared. Okay. You're welcome. This also will help you in biology class. Because these are plus, right? These are all positive. So the same thing happens here because this is the first. This is first, outer, inner, last. So it's the same thing, right? First, outer, inner, last. So when you add them all together, you get x squared plus xa plus xa plus a squared, which gives us our special case that we can just jump to, which you've talked about. X plus a quantity squared is equal to, see, we have 2 of these, x squared plus 2ax plus a squared. Okay? This is always true. We proved it by using the letters. Okay? So if I go in here and I say, okay, well, what's x plus 8 quantity squared, right? Do I have to do all of this? Nope. I know that this is going to be x squared plus twice ax plus a squared. So a in this example is 8. So I say this is equal to x squared plus 2a. 2 times 8 is 16. X plus a squared. 8 squared is 64. I don't have to multiply this out. I can use my form. Let's try another example. X minus 3 squared. Okay, well, we have a minus. Ooh, minus doesn't have to be scary. Same form, x squared. And then you would say plus, but what is the plus? Well, it's 2 times negative 3. 2 times negative 3 equals negative 6. So this plus turns into a minus. Okay, we're just going to get rid of it now. because it's minus 6. 6x, double this, right? And then plus, what is negative 3 times negative 3 squared is positive 9. Boom, done. So here's the difference. If you want to look at the form, when this is positive, this is positive. When this is negative, this is negative. Easy peasy. Okay, now we come to what's called the difference of squares. Now, this was the whole thing squared. And when we FOILed it out, we got this, right? So the difference of squares is exactly that twice. So difference means what in the world of math? This is subtraction, okay? Subtraction. So we have what happens here. So difference of squares is it's a really incredible phrase because it means the same thing in two different ways. It's almost a play on words in the English language. Because what you're saying is x plus a, x minus a, times x minus a, as opposed to this, right? Instead of the same thing multiplied, we take the difference of squares. So this would normally be perfect squares, but it's not. They're different, right? A positive and a negative. That becomes the difference of squares because the same way that this is plus xa and this is plus xa and you get twice, when you multiply down below, you get a minus. So let's do the square so we can just see it, okay? If we do the exact same square, you have x plus a, x minus a. We'll do minus the better way. X minus a. You get x squared plus ax minus ax minus a squared. Now you'll notice these are opposites. They're inverses, right? These are inverses. So they cancel each other out, right? They cancel each other. So when that happens, instead of this, right, you end up simply with this, which is x squared minus a squared. I don't need this, sorry. Which is the difference, subtraction, difference, subtraction of squares. These are both perfect squares. So for example, x plus 2, x minus 2, we just know the form x squared minus 4 squared. This is most helpful in reverse. So when you're factoring, x squared minus 81, you can notice that this is x squared and this is 9 squared. So this is equal to x plus 9, x minus 9, the difference of squares. Difference of squares. what makes it even more useful, let's try another example. Try x to the fourth minus 16 factor. Well, this is x squared, and this is 4 squared. So this is equal to x squared plus 4 times x squared minus 4. Let's make that look a little nicer. But now this can be factored. This is x squared, and this is 2 squared. So then the whole thing, you see it? Then this whole thing can become x plus 4 times x plus 2, oops, this is x squared, x plus 2, x minus 2. So this factored is this. X squared plus 4 times x plus 2 times x minus 2. So, special cases are very helpful. We have the binomial squared, and we have the difference of squares, and they are both
We're not sunny side.